Hi everyone, welcome back to K Science Academy. If you are joining us for the first time, this is K Science Academy, where we talk on physics, chemistry, mathematics and science facts. Today we are going to start one of the most important topics in mathematics, which I call the laws of indices. If you understand indices very well, topics like surd, logarithm, standard form and quadratic equation will be easier. And in this video, we are going to learn number 1, the meaning of indices, base and exponent, the laws of indices, and one simple example. Now let's get started. When we talk of indices, what we are actually saying in essence is that to what power are we going to raise a number? Like if you raise a number to a certain power, what is going to be your result? For example, looking at this, we have 2 raised to the power of 3. So when you have 2 raised to the power of 3 here, what we are trying to say is that you multiply 2 by itself 3 times. Now before we go into that, we can just look at this very well. Say when you have 2 raised to power 3, now this our 2 is what we call the base. Then this 3 is what we call the index. You can call it exponent and you can call it power. So we can say 2 raised to the power of 3, or we can say the base is 2, the power is also called the index, also called the exponent. So now this actually means we multiply this base. Indices actually mean we multiply this base with itself. How many times? 3 times. That is, you multiply your base by itself in accordance with the number of exponents you have. So that means we are going to have 2 times 2 times 2, and that's what? That's 8. So this is very simple, and this is just the introduction to indices. Now let's take a look at laws of indices. Let's take a look at the 9 to 10 laws of indices before we take one example. Now these are the laws of indices. We assume we have a and b to be a non-zero real numbers and m and n to be an integer. Now the first law is product law. We have a raised to power m multiplied by a raised to power n equals a raised to power m plus n. Now in this product law, we can see clearly that product law makes multiplication. We are multiplying 2 times together. Now looking at the first term, we have a base a. The second term, we have a base a. Now the moment we have the same base, we can go ahead to apply the laws of indices. Now we have the same base. We pick one of the base. We pick a. Then the multiplication will change to addition. That is, we are going to add the index or the power or the exponents, but we are not adding the base. You pick one of the base, you add the index or the exponent. That's why you have a raised to power m plus n. Now the second law, which is the quotient law, says this is just a division law. That is, a raised to power m divided by a raised to power n. You can write it in the fraction way, you can write it in the normal way, a raised to power m divided by a raised to power n. So here, instead of addition, we have subtraction. That's why we come about a raised to power m minus n. Now going to the third law, we have power of a power law. Now that is when you have a base raised to a power and the entire thing now raised to another power. Now we have a raised to power b, everything raised to a raised to power m, everything raised to power n. Now in that case, when you have power of a power, that is 2 power. So we multiply the powers together, and they will now be the product of the powers will now be what you are going to raise a to. Now look at this. We have a raised to power m, everything raised to power n. Therefore we have a raised to power m times n, which is mn. Now looking at the fourth law, we have the power of a product law. Now you have two different bases multiplying each other, then raised to power of n. Now what you do is you separate them, then raise them to the power of n. You pick a raised to the power of n, then you multiply it by picking b raised to the power of n. That's why you have a raised to power n times b raised to power n. That's the same thing as a raised to power n, b raised to power n. Now the fifth law is what we call the power of a quotient law. Now you have a over b, everything raised to power n. Now our numerator is a, which is base a, then the denominator is b, that's our base 2. Now in this case, we pick the numerator, raise it to the power of n, pick the denominator, raise it to the power of n. So we have a raised to power n over b raised to power n. Now the sixth law, which is the zero exponent law, this one is straightforward. Anything raised to power 0 is 1, provided that a is not equals to 0. That is, 0 raised to power 0 is undefined, but anything apart from 0 raised to power 0 is 1. Now let's go to number 7, the negative exponent law. Now we have talked about the zero exponent law. Now this negative exponent law is just like the normal way of writing our indices, like a raised to power n. But here we now have a negative integer, because we assume that our m and n are integer. Now we have a raised to power minus n. Now our minus is going to change to 1 divided by. So in that case, we have 1 divided by, neglect the minus, we are going to have a raised to power n. So when you see a raised to power minus n, you pick 1 over, then neglect the minus, that will now be a raised to power n, where your a must not be 0. The moment your a is 0, that's indeterminate, that is undefined. Now let's go to rule number 8, negative exponents of a quotient law. Now you have just like the quotient law. Now you now raise it to the power of negative integer, just like rule number 5, but now it is negative. So in that case, what we are going to do is just that we are going to change the denominator to the numerator and the numerator to the denominator. We interchange them. B comes up, then a goes down, then everything raised to power n. Then we can now say b raised to power n over a raised to power n. Now going to the 9th law, we have the fractional exponent law. That is, when you have a base and it is now raised to the power of your power is in form of a fraction, like a raised to power m over n. Now what you are going to do is, like, you raise your a to the power of m, then you take the square root, you take the nth root of the other denominator. That's why you have n root a raised to power m. That is, your denominator is going to be the nth root, then the power is now going to be your numerator. That's why m is our power, then n is our nth root. That's why you have nth root of a raised to power m. Then you can times say nth root of a and everything raised to power m is still the same thing, but your a must be greater than 0. Then the 10th law says that we have the fractional exponent law. That is, when you have a raised to power 1 over n. In this case, it's just like rule number 9, but m is now 1 here. In that case, you are not going to raise it to the power of anything, because anything raised to power 1 is that number. So that's why we have nth root of a. We don't need to put raised to power 1, because raised to power 1 is still a. Now the 11th law is equality of basis law. And if you have a raised to power m equals to a raised to power n, that means the integer, the power index, they are the same thing. If a raised to power m is the same as a raised to power n, definitely m and n is equal, since a and a is equal. Now the 12th point is the equality of exponents law. That's, if a raised to power m equals to b raised to power m, then a equals b. You know that in this case, the base, they are not the same, but the exponents are the same. So the moment the exponents are the same and you equate them, then that means the base should be the same, because that's what we talk about in the beginning, that in indices we must have the same base. If we don't have the same base, then we can't proceed, we stop there. But now, for you to say a raised to power m is equals to b raised to power m, that means a and b are equal. So a can be 2 and b is 2. Let's take a look at this example. This question says, simplify 2 raised to power 3 multiplied by 2 raised to power 2 all over 2 raised to power 4. Now look at it. We calculate that here our base is 2, here our base is 2, here our base is 2, here our exponent is 3, here our exponent is 2, here our exponent is 4. Now let's start with the numerator. Looking at this, we have the same base, and the moment we have the same base, we can go ahead to pick one of the base. So we can say we pick 2. Now we have exponent to be 3 here, exponent to be 2 here. And law of indices, the first law, the product law, says when we have multiplication, it changes to addition, and it is not addition of the base, it is addition of the exponents. So we have 3 plus 2 all over 2 raised to power 4. There is no problem here. Then we'll say it is equals to 2 raised to power 3 plus 2, that's 5 over 2 raised to the power 4. Now looking at this is division rule, the second law of indices. We have 2 as the base, 5 as the exponent, 2 as the base, 4 as the exponent. Now we can see that the base are equal, so we pick one of the base. Now according to division rule, anything division will change to subtraction, so you pick the first exponent 5, then this change to negative minus 4. So we are going to have 2 raised to the power 1, and 2 raised to the power 1 is just what? 2, because according to that law, any number raised to the power 1 is that particular number, so our final answer is 2. So this is just the introduction to law of indices. In the next video, we are going to solve more example on product law and many other laws. We are going to take a question where we can combine all the laws before we are able to solve it. So don't forget to like, share and subscribe to K Science Academy, and also subscribe to our YouTube channel at K Science Academy. Bye.